An important buffer in the body is composed of an aqueous solution of carbonic acid and bicarbonate ions. Because carbonic acid is a weak acid, at equilibrium some molecules dissociate to form bicarbonate ions and hydrogen ions. The buffer contains many molecules of carbonic acid, many bicarbonate ions, a few hydrogen ions, and many water molecules. Adding a strong acid contributes many hydrogen ions to the buffer solution. However, the buffer acts to minimize the effect on pH by mopping up the excess hydrogen ions. The bicarbonate ions in the buffer combine with the hydrogen ions from the strong acid to produce molecules of carbonic acid. As most of the excess hydrogen ions are thereby removed from the solution, the pH only drops by a small amount. Adding a strong base contributes many hydroxide ions to the buffer solution. However, the buffer acts to minimize the effect on pH by mopping up the excess hydroxide ions. Molecules of carbonic acid in the buffer combine with the hydroxide ions from the strong base to form bicarbonate ions and water. In addition, the few hydrogen ions present in the buffer also react with the hydroxide ions from the strong base to form water. Because this process removes hydrogen ions from the buffer, the equilibrium between the components of the buffer shifts. This causes additional molecules of carbonic acid in the buffer to dissociate into bicarbonate ions and hydrogen ions, maintaining the supply of hydrogen ions in the buffer. As a result, most of the excess hydroxide ions are removed, and the pH of the solution only increases by a small amount.